Hi everyone, this is Firan and welcome to Study Windows. Today we are going to learn Mathematics Part 2, Euclid's Division Lemma. Euclid, a famous mathematician who has invented this division lemma. So Euclid's Division Lemma. Before going to the discussions, we need to know what the lemma is. A lemma is a proven statement used for proving another statement. So division, we all know division. How do we do division? That's 9 divided by 4. So how we write? We just draw this and we write 9 here and 4 here. So 4 2s are 8 and 9 minus 8 is equal to 1. So we do the division in this way. So from this we know if you multiply this 4 and 2, so 4 multiplied by 2 and we add this 1. So 4 multiplied by 2 plus 1, this entire things is simply equal to this. So we can write 9 is equal to 4 multiplied by 2 plus 1. So this is a simple equation. Now if it is 7 divided by 3, then we will write 7 here and 3 here. So 3 2s are 6 and 1 here. So the equation will change. 7 is equal to 3 multiplied by 2 plus 1. So it's a very simple, right? Now this 7, it is called dividend. It is symbolized as A. This 3, it is divisor. It's symbolized B. And this 2, green color, it is quotient. It's Q. And this 1, and this is remainder. That's symbolized by R. So we can write from this 7 is equal to 3 multiplied by 2 plus 1. Dividend is equal to divisor multiplied by quotient plus remainder. So this 7 is the dividend, this 3 is the divisor, this 2 is the quotient, and this 1 is remainder. We can generalize this equation like A is equal to B multiplied by Q plus R. So A is equal to BQ plus R. So we got A is equal to BQ plus R. Now we are saying if A and B two positive integers, then there exist unique positive integers Q and R. Then A is equal to BQ plus R, where value of R will be greater than is equal to 0 but less than B. So we will try to understand with an example. Let's consider 7 apples are there. We'll divide 7 apples. So total number of apples are 7. So 7 is dividend, that is 7, which we have considered as A. Now we will divide apples in such a way that each person will get 3 apples. Okay, so this 3 is the divisor, which we have considered as B. So we have given to this apple to Mr. A and he is very happy. 4 apples will be left. Now another 3 apple we will give it to a lady and she is very happy with this 3 apple. Total 6 numbers of apples we have given. So 3 multiplied by 2 is equal to 6. This 1 apple is remaining. So this is the remainder. Now positive integer 3 and 7, these 2 and 1 are the unique value or unique integers. Now for each 2 positive integers there will be 2 unique values. It may be 3 7, it may be 5 8, it may be 9 10, it may be 10 100. This one number of apple is left. This number of apple should not be 0.5, half or 0.6. It should be 0 or a positive number without fraction. So we can say this value of remainder r greater than is equal to 0. We know integer means it should not have any decimal point, so it should be greater than is equal to 0. So r greater than is equal to 0. If the number of apples is 8 instead of 7, then what will happen? Then remainder will be 2. So there will be 2 apples. So it is possible. But can you tell me that this remainder can be 3 apples? No, it is not possible, because if you have 3 apples, you should give to another person. So this r should be less than b. So r should be less than 3. So we can say r should be greater than is equal to 0 and less than b. So it is proved that if a and b two positive integers, then there exist unique integers q and r, then definitely it will satisfy that a is equal to bq plus r, where r greater than is equal to 0 but be less than b. To understand this properly, we will do some example, so that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1, where q is some integer. Before solving the question, we should do the followings. Read the question properly and up to the end. Understand the question, what the question is all about, and understand what is asking exactly. So read the question properly and up to the end. So we will read the questions once again, so that every positive even integer is the form of 2q and every positive odd integer is the form of 2q plus 1, where q is some integer. Understand the question. So here, if you see positive even integer, we have already learned integers. It means minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6 and so on. So without any decimal point, all the numbers are integers. And if I say positive integers, then all the negative values will vanish. So only 1, 2, 3, 4, 5, 6 and so on. If I say positive even integer, we know even means it is multiple of 2 or divisible by 2. So 2 we can say is a divisible by 2, 4 is also divisible by 2, 6 also divisible by 2. And in the same way, these 1, 3 and 5, these are positive odd integers. These cannot be divisible by 2. Now we have to see that all the positive even integers can be written as 2q and all the positive odd integers can be written as 2q plus 1. So these two things we have to prove in this question. We know from Euclid's division lemma a is equal to bq plus r, where r greater than is equal to 0 and less than b. So from this question, if you see 2q and 2q plus 1, here what is 2? 2 is the divisor. We know from Euclid's division lemma a is equal to 2q plus r. So 2 is the divisor. Now from this Euclid division lemma we can say r greater than is equal to 0 and less than 2. How many r value is possible? We know r should not be any decimal number. 2 values are possible. One is 0 and another one is 1. So 2 values are possible. So a can be written as 2q plus 0 and 2q plus 1. So 2q plus 0 means 2q and 2q plus 1. So a can be written as 2q and 2q plus 1. Now if you see a is equal to 2q, you will understand that it is 2 multiplied by q. So a is equal to multiple of 2 or it is divisible by 2. So it is positive even integer. And 2q plus 1, it is simply 2 multiplied by q plus 1. So this 2 multiplied by q is divisible by 2 2q is equal to even number, plus 1 is equal to odd number. So even plus odd is odd number. So it is positive odd integer. So we can say every positive even integer is the form of 2q and every positive odd integer is the form of 2q plus 1. Now one more example. Show that any positive odd integer is of the form 4q plus 1 or 4q plus 3 where q is some integer. We know from Euclid's Division Lemma a is equal to bq plus r, where r greater than is equal to 0 but less than b. From this question, you can see that 4q plus 1 and 4q plus 3. Now 4, what is this? 4 is the divisor. We know from Euclid's Division Lemma a is equal to 4q plus r. 4 is the divisor. Now from Euclid Division Lemma we can write r greater than is equal to 0 but less than b is equal to 4. So how many r values are possible in this equation? Greater than is equal to 0 and less than 4. There are 4 values are possible. Maybe 0, it may be 1, it may be 2 and it may be 3. No fraction is possible here because r is positive and without any fraction. So a's value can be 4q plus 0, 4q plus 1 or 4q plus 2 or 4q plus 3. 4q plus 0 means 4q. Now a is equal to 4q. If we see 4q is multiple of 2 or it is divisible by 2. So multiple of 2 means it is even number. So it is positive even integer. If we see 4q plus 1, it means 4q, which we have already seen that it's a multiple of 2 and plus 1. So even number plus odd number is equal to odd integer. So 4q plus 1 is equal to positive odd integer. 4q plus 2. So here also we can write 2 into 2q plus 2. Here 2 into 2q means 4q is multiple of 2. So it is even number and 2 is also even number. Even plus even number. So it is even number. So 4q plus 2 is even number. 4q plus 3. We have already seen 4q is 2 into 2q positive even number. And 3 is odd integer. So even plus odd is equal to odd integer. So 4q plus 3 is positive odd integer. So we have seen that 4q plus 1 and 4q plus 3 both are positive odd integer. So we can say any positive odd integer is the form of 4q plus 1 or 4q plus 3 where q is some integer. Now we will see one more example. Show that the square of any positive integer is the form 3m or 3m plus 1 where m is some integer. We know as per Euclid Division Lemma is equal to bq plus r, where r greater than is equal to 0 but less than b. Here what is 3? 3 is the divisor. We know from Euclid's Division Lemma a is equal to 3q plus r, and as per Euclid Division Lemma remainder r greater than is equal to 0 but less than 3. So 3 value is possible, 0, 1 and 2. So a's value can be 3q plus 0 or 3q plus 1 or 3q plus 2 or 3q plus 1 or 3q plus 2. Now we have to prove that the square of positive integers like 3q, 3q plus 1 and 3q plus 2 should be in the form of 3m or 3m plus 1. Let's try to prove this. So we'll take a is equal to 3q. So we'll make the square of 3q's. So 3q square is equal to 9q square is equal to 3 into 3q square, so that it will be multiple of 3. So 3m, where m is some integer and its value is equal to 3q square. So 3q square we can written as 3m. Now 3q plus 1. So 3q plus 1 square is equal to, we know a plus b whole square is equal to a square plus 2ab plus 3a square. Here also we will apply the same thing. So 3q square plus 2 into 3q into 1 plus 1 square. So is equal to, we can write 3 and in bracket 3q square plus 2q plus 1. So we can write is equal to 3m plus 1, where m is some integers. M is equal to 3q square plus 2q. So 3q plus 1 square can be written as 3m plus 1. Now 3q plus 2. So square of 3q plus 2 is equal to 3q square plus 2 into 3q into 2 plus 2 square as per a plus b whole square formula. So we can write 3 into 3q square plus 3 into 4q plus 3 plus 1. What we did here, we have to get a common of 3, so that's why we separate 3 from 3q whole square. And if you see here, 2 squared is equal to 4, but we have written 3 plus 1, so that we can make a multiple of 3. We are taking common 3, bracket 3q square plus 4q plus 1 plus 1. So 3m plus 1. So 3q plus 1 whole square can be written as 3m plus 1, where m is the integer. This and m value is 3q square plus 4q plus 1. So square of 3q plus 2 can be written as 3m plus 1. So we have seen that square of any positive integer is the form of 3m or 3m plus 1, where m is some integer. If you like study windows, like, share and subscribe, and don't forget to click the bell icon. Check it out our next video. Thank you so much for watching our videos. Please subscribe our channel for latest updates.